Black holes. Many of you already know what a black hole is, but they're still one of the most mysterious objects in the universe and a nearly infinite source of energy. We'll be exploring the possibility of powering a civilization with this source. So what is a black hole? Well, a black hole is a singularity, a point in space where density approaches infinity. However, while all black holes are singularities, not all singularities are black holes. For example, before the Big Bang, the whole universe existed as a singularity. Usually, a black hole will look something like this. At the center is the singularity, then there's the event horizon, and finally a photon sphere. This is where gravity is so strong it forces photons to enter an orbit around the black hole. Larger stars turn into larger black holes and vice versa. However, a black hole can also become larger if it collides with another black hole or takes in more mass, like if you throw stuff into it. You and the universe will lose the mass and energy, and the black hole gets a bit larger. Importantly, black holes lose mass through a process called Hawking radiation. Near the event horizon, quantum fluctuations, the theory that extremely short periods of time energy can be measured to be greater than zero, form virtual particles, some of which fall back into the black hole and the rest leave as photons, but ends with a net loss of energy from the black hole. Smaller black holes radiate away quicker than larger ones, thanks to the entropy of black holes. Now you're probably wondering how to harvest black holes. The answer is actually quite unintuitive. To harvest energy from a black hole, you have to throw mass into it. Now I know what you're thinking. Throw mass into it. Wouldn't that mean losing energy? And the answer is yes. Technically it would be, but certain factors come into play that make the loss worthwhile. At the point where you would consider harvesting a black hole, most, if not all the stars in the universe would have already burned out, leaving behind a black hole or solid cores of iron. And thanks to Hawking radiation, the energy a black hole loses can be used by, say, advanced solar panels. The process would go something like this. A civilization comes across a small black hole and nearby cores. They will then bring chunks of the core and toss them into the black hole. The black hole takes in the matter and it is lost. But it also sustains the lifespan of the black hole and thus its radiative rate, which given its size is relatively fast. The civilization then takes the energy released by the Hawking radiation. So the black hole acts like a converter, converting mass into energy. Rate of 5 kilograms per second, this civilization can generate 450 quadrillion joules of energy per second. Now this sounds ludicrous. 5 kilograms per second, that's like chucking an entire gallon of milk in the rubbish bin. But in reality, it's not. Our sun has a mass of about 200 octillion kilograms of matter. When it dies, it will leave behind a similar amount in kilograms of iron. If you were to get rid of that amount of iron, even at 5 kilograms per second, it would take 1.3 sextillion years to be fully depleted, which would be ample time to find another core and restart the process. So the next time you find yourself in the year 14 trillion, you can rest easy knowing how to get energy from where there shouldn't be any.